Hello, I'm Jonathan Powell. This is for server Windows Server 2019 spring semester at Southwestern Illinois College. Uh, Instructor Brian Link. Um, this is understanding RAID and RAID types. Get right into it. A RAID 0 or disk striping is fast and not fault tolerant. That is, data bits are written from one disk to the next, not through the disk and through the next disk. They're written across. So the picture of the illustration, block of data. You see how A and B are lateral, C and D. So A, C, E, G, and I is one disk. B, D, F, H, and J is another disk. So I'm just reading it along. Data in one block is divided into multiple chunks of the same size. And then the data chunks are sequentially striped across the two disk drives. And noting that only one copy of the data strips exist on the drives. So you get more an idea of a feeling of more storage, and you are. So this is how you would, if you have 14 random size disks, for some reason you want to be able to see them as one. You may want to do a RAID 0 just to make yourself make it appear you have a lot more storage. But again, if any one section, if any drive fails, it corrupts everything else, and it's as if it's one drive. So all the data can generally be lost. RAID 1 disk mirroring, common home model. I say common just because that's what I got. So you go to Micro Center, you get the one that comes with two hard drives instead of with one. So you need the two hard drives, but let's go down there. The block of data still not striped. All as you can see, A, B, C, D, E, and F are all contained in contained in both disks. So whatever is written to disk drive drive A is the same as on hard drive B. The data set is divided into chunks of the same size. The chunks are stored in disk 1, and an exact copy of each chunk is stored in disk 2. Thus, a mirror of disk 1 is created. Of course, now, if you have two, let's say you have two 2 terabyte drives. That gets a little confusing. You have two 1 terabyte drives. So you stick them in there, you still only have 1 terabyte. You don't have 2 terabytes because each one's copied straight over. So you're not gaining this massive amount of storage. You're just increasing the chances that if one fails, you won't lose everything in the other. And I use it for the things I deem irreplaceable. Pictures, digital pictures, things like that. Where if I lost it on one, I'd hopefully wouldn't lose everything. RAID 5, disk striping with parity. And I got some of these illustrations up here so you can try and work them out in your head because heck, that's what I had to do. I've learned about OR gates, exclusive OR gates. I've learned digital, and I still have to go back and review, okay, how does an exclusive OR work? It's fault tolerant by calculating data in 2 drives and storing the results on number 3. Diagrams use 4 drives. So these examples are on as showing 4 drives. But so it's as if the result XOR gate. Parity is a variable and output, not intelligence. So again, it's the parity or the answer to the equation or whatever is simply is simply a logical result of the XOR. So we'll look at the first picture real quick, see if I can get this out real quick. So if A, B, and C, if it's a 0, 0, 0, then the output would be a 0. So it shows in the middle picture a little bit better on how you place it in the left diagram. So it's showing that disk 2 had a failure on there, the red with the stars and the lightning strike. So the green represents the parity bit. Again, it's just stored on the fourth disk, but again, that's not really data. It's just a sum. And it's used that if you replaced the bad drive, the results of the 2, 0 and a 1, would result in a 1. So that's how what it uses to rebuild the hard drive after you've replaced it. And on to the next one. RAID 10, 1 plus 0, stripe and mirror. So simple enough. Keep adding it together. So we're striping to increase our to increase our storage capacity, but we're also mirroring them. So now we have 2 drive striping. So you, for argument's sake, you're not mirroring your capacity, but you're mirroring that capacity. Hardware-software RAID refers to processing. Software is... Spray this rabbit. All right, that should eat up like 15 seconds. Refers to processing. Software, OS and processor intensive through an application. And hardware RAID, processing handled separate from the PC or server utilizing additional drive slots. SDS, software-defined storage. Software RAID utilizing storage within the server. Virtualized networks with local on-site storage. S2D, storage spaces direct. This is Microsoft's non-proprietary separation of software managers and storage hardware. Storage media stays dumb. An attempt to expand. So I put that note. Essentially, that if certain systems, you have to stick with their name brand. So S2D is trying to eliminate the need to keep things vendor specific. And why we do what we do. High availability. It's the calculation of scheduled, unscheduled interruptions of service compared to required uptime or downtime as dictated by company policy, service level agreements, and consumer expectation. Thank you for watching.